myself Harsh, and today we are going to discuss the ninth problem from CP-31 sheet by TLE Eliminators under the 1100 rating range. So let's go to the TLE Eliminators website. Here you have clicked CP-31 sheet, then you have 1100 rated box clicked, and here is the clickable link to your problem. So let's move on to the problem. So the name of the problem is cardboard for pictures. Okay, so let's see what the problem says. Problem says that Mircea has n pictures. The ith picture is a square with a side length of SI centimeters. Okay, so there is a person having n pictures, and the ith picture is a square of whose side length is SI. He mounted each picture on a square piece of cardboard so that each picture has a border of W centimeters of cardboard on all sides. So as you can look, let's suppose a person has this blue picture, and now this blue picture is mounted on a cardboard so that the picture has some border right now, isn't it? It has some border which is said to be W. In total, he used C square centimeters of cardboard. So the total area of the cardboard that he has used is told to be C. Now given the picture sizes and the value of C, it is told to you that can you find a value of W. That is, the person has n pictures. So like see in this figure, the person has 3 pictures, and every picture is stuck on some cardboard, and such that every picture has some border, and all the borders are same. Like if this has a border of some W, then over here also the border is W, and over here also the border is W. Now it is told that the total area of this cardboard, like this is one cardboard, this is the other, and this is the other, right? So the total area of the cardboard is actually C. So the question wants that if you are given the total area of the cardboard and the side length of the pictures, then can you find this width? This is actually what the question is. So the number of test cases are of the order of 1e3, that is 1000, and the number of pictures are of the order of 2 into 10 power 5, and area is of the order of 10 power 18. Second line contains n space separated integers SI, that is the sizes of the paintings, and it's given the sum of n over all the test cases does not exceed 2 into 10 power 5. And additional constant is given that a W will always exist, that there will exist some W, that is the width of this, that is the border of this picture, so that for the same W, that is keeping the border as same, you have some area produced, and that area matches the value of the area that is given. Okay, so you need to output W for each test case, for which exactly C squared centimeters of cardboard is utilized. So let's understand what actually the question wants us to say. See, so what you are given is, you are given n pictures, okay, and every picture is a square sided picture such that the side length of the square is given to you. So let's suppose you have S1, S2, S3, you have 3 pictures, okay. So the side length of the pictures S1, S2 and S3 are respectively given to you. So there is a square board of side length S1, there is a square picture of side length S2, there is a square picture of side length, let's suppose S3, okay. Now what they have told is, you are mounting this picture on a cardboard. So let's suppose this is a cardboard, such that this picture has a border of W. So this W is exactly the same from all the sides. Now the interesting part is, you are mounting all the pictures separately on a cardboard, and for every picture the border is W. For every picture the border is W. Okay. For this picture as well the border is W. So these all are W. Okay. So the border is W. Now what they have told is that the total cardboard that you have used, total area of cardboard used is equal to C. This is something that is given to you. So the question is that can you find W? What is the value of W? This is actually what the question is. Okay. So I hope all of you understood the question. Now, before proceeding with the solution, first of all, let's analyze the time complexity. So if I look for expected time complexity, if you look one thing, you have n of the order of 1e5, right? That is 10 power 5. So any solution that works in big O of n log n, big O of n, big O of n square root n, or big O of log n, big O of square root of n, anything that works within this will surely give you then AC verdict. But if you are designing a solution that is working in something like big O of n square or anything above this, like big O of n square log n, something like this, so this will definitely produce TLE, right? So you have to design a solution that works within these time constraints. Cool? Okay. So how we can actually proceed with the solution? What we can do? So we know that for every picture the W is fixed, right? Let's analyze a picture. Let's suppose there is a picture having a side length of S and I am mounting it on a cardboard such that the width produced is W. Isn't it? Now can you say me that what is the area of cardboard I have used in this? First of all, let's see the side lengths of this cardboard. What will be this side length? Do you agree that this side length is nothing but, if I just expand it a bit, then this is S, this is W, and this is W. So don't you all agree that the side length is nothing but S plus 2W? If the side length of the picture was S, then the side length of the cardboard is S plus 2W, and it is the same for all the sides. Isn't it? So the entire side length is S plus 2W. So actually the area of the cardboard used is nothing but S plus 2W square. Do you all agree? Do you all agree with me in this? If this is understood, then can I say that if I have n pictures, with side lengths as S1, S2 up till Sn, then can I say the area of cardboard utilized or area of cardboard used is nothing but S1 plus, if I am assuming the width as W, then it is nothing but S1 plus 2W square plus S2 plus 2W square plus up till Sn plus 2W square. And this is already given to you, it is given to you as C. And you know S1, S2 and Sn, and you only need to find this W, right? Now how we can actually find this W? One method is that we know that the minimum value of W is 1, right? The minimum value of W is 1. What can be the maximum value of W? If I just try to keep some upper bound, what's the maximum value of W can be? So if you all look one thing, you are given that C, the maximum value of C is 1E18. C is of the range of 1E18, it is already given to you. So can I say that my W will be lesser than 1E9, right? Because if I square 1E9, if I just square 1E9, I will get 1E18, right? I will get 1E18. And you can see in every term we are at least having W square. We are at least having W square in every term, right? So I know that my W will be lesser than 1E9. So let's say that the minimum value of W is 1 and maximum value of W will be lesser than 1E9. Let's assume 1E9 if I am doing that. And now if I try to do this, that for every W I try to see that the particular W is correct or not. That is, what I do is I just iterate over all my border length, possible lengths, that is W, from 1 to 1e9, and when I get that, okay, for a particular border, I get that, okay, the area is equal to C, so I will say that, okay, that W is my answer. But what's the time complexity in that case? If you observe, you are iterating over all these W's, right? In the worst case, how many number of iterations you will do? 1e9, right? Multiplied by, for every W, to calculate the area it is actually utilizing, how many what is the number of iterations you need to make? You need to go to each and every pictures, right? So can I say that for every W, you will need big O of n iterations? So the total time complexity becomes big O of n multiplied by 1e9, which I can say will definitely produce TLE, right? It will definitely produce TLE. So you have to work with some mechanism so that this W does not get to 1e9. Like, okay, for a particular W, we are iterating over big O of n. But if we limit our search space of W, then the things will surely work, right? So how we can actually do that? So if you observe one thing, if I say you that I have a picture of side length 2 and I have a picture of side length 3 and I am mounting it on a cardboard. Okay, I am mounting both the pictures on the cardboard. Let's suppose I keep my W as 1. If I keep my W as 1 with W as equal to 1, can you compute the area of cardboard utilized? Area of cardboard utilized will be 2 plus 2 square, that is 2 side length plus 2W. So 2 plus 2W is 2 square plus 3 plus 2W square. So how much it comes out to be? It comes out to be 16 plus 25, right? Which is 41. Similarly, with W is equal to 2, if I compute the area, what will I get? 2 plus 2W is nothing but 4. So 2 plus 4 square plus 3 plus 2W square. So the area that I get is 6 square plus 7 square. That is 36 plus 49. That is nothing but 85, right? 40, 30, 70, 79, 85. So, did you observe one thing? Once I increase the value of W, my area increased. And it is quite logical, right? As much as I increase my width or the border length, if I say, so this term will increase, this term will also increase, and every term is going to increase because this SI is fixed. S1, S2, Sn is fixed. Only this term is varying, right? So once I increase my W, all these terms are going to increase and my area is also going to increase. So do you agree that, okay, if my final value of W is 5, for which the area computed becomes C, if my final answer is W is equal to 5. So if my final answer is 5, then do you all agree that for W equals to 1, 2, 3, 4, the area that I will get will be actually lesser than C. For all these values, the area I will get will be lesser than C. And for all the values greater than 5, for all the values of W greater than 5, that is 6, 7, 8, 9 up till 1e9, for all the W's greater than 5, the area that I will get, it will be greater than C. Do you all agree? So if I compute a function, which returns me true if area is lesser than equals to C for a particular W, and it returns me false if area is greater than C for a particular W. So can I say that I will be able to form this will actually be a monotonic function if I just iterate over W's? So the result that I will get is something like this: true, 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 false, 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 false. And what I want the last true, right? That is the biggest value of W at which my area is lesser than equals to C, because at this particular W my area will actually become equal to C. And as the question says, there exists a W for which area becomes equal to C. So this W will actually be my answer. And how we can actually solve questions of like this monotonic or predicate functions? We can solve it using binary search on also. So this is actually a classic question of binary search on answer, and why it is actually working, because we already saw that while we were traversing over W one by one, our complexity was this, isn't it? But using binary search, what we can do is we just initialize our lower value with 1 and let's suppose the higher value as 1e9, and now we know that okay, our answer exists between 1 and 1e9. We find a mid value, and if at this particular W my area becomes greater than C, so what I can say that okay, I am lying over somewhere over here, right? So my search space, I can say that okay, let my L remain the same, but my R will change to mid minus 1. My R changes to mid minus 1. And this is how only in one iteration I reduced my search space to half. So at every time I am reducing my search space with half, and that's the reason the complexity becomes logarithm value of 1e9, which was earlier the linear value of 1e9, that is basically 1e9. So from linear time complexity we shifted to logarithm time complexity, and this will definitely pass our constraints, because for every W the maximum time we take to compute that for that particular W, our area is lesser than equals to C or greater than C is actually big O of n. So the total time complexity will become logarithm 1e9 multiplied by big O of n, and this will definitely pass the constraints. So this is how we actually optimized our search space, that is basically reduced our search space at every iteration by half and lowered down our time complexity. So let's jump onto the code and see the implementation part. So this is actually the code to your problem. First of all, I have taken number of test cases as input, and then for every test case I have called this solve function, which actually solves the question for me. Then I am taking the number of pictures and the total area as an input. Then I constructed an array A of size n that basically takes the side lengths of the pictures. Then I just initialized my lower value of W with 1 and the higher value with 1e9 and initialized my answer to -1. Now while this L is lesser than equals to R, first of all I am computing the mid, and I am initializing the sum of all cardboards initially with 0. Now what I do is I know that this mid is actually now my W, that is the border width, right? So just I have iterated over all the pictures. What will be my side length of the cardboard? Side length of the cardboard will be AI plus 2 into W, that is 2 into mid, right? So my area of cardboard will get increased by square of this value, right? So A of I plus 2 into mid multiplied by A of I plus 2 into mid. Now if my cardboard area till now becomes greater than C, so what I am doing is I am breaking. Now why I am breaking with this? Why I am not continuing with this for loop and then checking after that? See, it may happen that if I continue from here, my integer, I get an integer overflow, because this value may be very large, right? So I am adding these values to this sum all, and it may happen that if I keep on adding even when sum all is greater than C, because once sum all becomes greater than C, I know that I can never achieve the total sum of areas of cardboard as equal to C, because it is going to increase only, right? So once it becomes greater than C, what I am doing is I am breaking, because I know that if I continue from here on, so it may happen that to my sum all I keep on adding the values and I get an integer overflow. So that's the reason once my sum all, that is the sum of areas of cardboard, till now becomes greater than C, I am simply breaking. Now after coming out of this for loop, if my sum of areas of cardboard it's lesser than equal to C, so what I know, if this is the case, so I know that I am standing somewhere over here, right? I am standing somewhere over here. So I know that okay, this can be my answer. This can be my answer. So initialized my answer to mid and shifted my lower value of the search space to mid plus 1. Else I am shifting my higher value to mid minus 1. Once I am done with this while loop, I know that my answer variable actually stores the W, that for which I get the area exactly equals to C. So I am simply printing my answer. That is how this code actually works. So if I talk of time complexity over here, so this loop takes a time of n, that is taking input, and this loop, the while loop, that is L and R, since I am reducing the search space by half at every iteration, so this actually takes log of 1e9 time, and inside this if you look, inside this, if you look, I am running a loop of n, right? So the total time complexity for this is log of 1e9 multiplied by n. So sorry, I am running a loop of n. So the total time complexity in this case is log of 1e9 multiplied by n. So I can say that, okay, the time complexity is, for every test case, the time complexity is big O of n into log of 1e9, which will definitely pass the constraints, right? Because log of 1e9 is something around 30, because this is of base 2. So log of 1e9 is something around 30 and n is of order 1e5. So this will definitely pass your constraints. If I talk of space complexity, so I am making an array A of size n and rest I am not utilizing space anywhere, rest all are of constant space. So I can say that, okay, the space complexity is big O of n, which is well within the constraints and it will definitely pass, isn't it? So I hope all of you got it. Thank you.